A force is push or pull measured in newtons. One force we are very familiar with is force of gravity or weight. The very concept of push and pull simply direction. Thus, force are vectors. Direction of the weight is down towards center of the earth. Formula: W equals mg. Mass is in kilogram. G is acceleration due to gravity, 9.81 meter per second. Calculate the weight of 25 kilogram object. Mass is 25 kilogram. Acceleration due to gravity, 9.81 meter per second. Weight is equals to mass times acceleration due to gravity, 25 times 9.81, 245 Newton. W inherits its direction from the fact that G points downward. We sketch the mass as point particle dot and the weight as a vector in free body diagram. As a dot, weight is downward. This is free body diagram. Certainly, there are other forces beside weight that we are familiar with. For example, when you set a mass on a tabletop, even though it stops moving, it still has a weight. The implication is that tabletop applies a counterforce to the weight called normal force. Note that the weight and normal force are same length, they are balanced, or they are in equilibrium. Normal force is often called a reaction force as well. Tension T can only be pull and never a push. Friction tries to oppose the motion. Friction is parallel to the contact surface. Normal is perpendicular to the contact surface. Friction and normals are mutually perpendicular. Friction and normals are surface contact forces, and the weight W is an action at a distance force. Weight is sketched from the center of an object. Normal is always sketched perpendicular to the contact surface. Friction is sketched parallel to the contact surface, and tension is sketched at whatever angle is given. An object has a tension acting on it at 30 degrees as shown. Sketch in the force and draw a free body diagram. Weight is drawn from the center down. Normal is drawn perpendicular to the surface from the surface. Friction is drawn parallel to the surface. Free body diagram. Weight is down, reaction is up. Friction is opposed motion, and the tension is 30 degrees to the horizontal. The resultant force is just a vector sum of all the forces acting on a body. An object has a mass of 25 kilogram, a tension of 50 Newton, and a friction force of 30 Newton are acting on it as shown. What is the resultant force? Since the weight and the normal force cancel out in y direction, we only need to worry about the force in x direction as the object moving horizontally. The net force is tension 50 Newton minus the friction force 30 Newton. And that gives us 20 Newton to the right. Example, an object has exactly two forces, F1 equals to 50 Newton and F2 30 Newton applied simultaneously to it. What is the resultant force's magnitude? Net force equals to F1 plus F2. So we simply graphically add the two forces. We can move the vector around as long as it's parallel to the original direction. Ending of the first force is beginning of the second force. And that gives us net force. Magnitude is given by Pythagorean theorem. F net squared equals to 50 squared plus 30 squared. And F net equals to 58 Newton. And that is the resultant force's magnitude. What is the resultant force's direction? Direction is measured from the positive x-axis. Opposite and adjacent are given directly, so use tangent. Tan theta equals to opposite. Our adjacent opposite is 30 Newton, adjacent is 50 Newton. So 30 over 50 equals to 0.6. And theta equals 2 inverse tangent. That gives us 31 degree. Example, an object has exactly two forces, F1 50 Newton and F2 30 Newton applied simultaneously to it. What is the resultant force's magnitude? Begin by resolving F1 into its x and y component. X component, that's adjacent, 50 times cosine 28 degree is 44 Newton. Opposite is sine, so 50 times sine 28 degree, which is 23 Newton. Net force in x direction, just 44 Newton. F net in y direction, we have 23 Newton plus the 30 Newton. That gives us 53 Newton. So F net squared equals to F net x squared plus F net y squared. That's F net squared equals to 44 squared x component and 53 squared in y component. So F net equals to 69 Newton. Solid friction. Recall that friction acts opposite to the intended direction of motion and parallel to the contact surface. Suppose we begin to pull a crate to the right with gradually increasing force. We plot the applied force and the friction force as function of time. Tension in green, friction in red. Static friction is applied. As tension increase, the static friction also increase. And static friction reach maximum value. When object started moving, dynamic friction take over. During the static phase, as a static friction force exactly matches the applied force. Static friction increase linearly until it reach maximum value, maximum static friction. The friction force then almost instantaneously decreases to a constant value Fd called dynamic friction force. Static friction is larger or equal to 0 and smaller or equal to maximum static friction. Dynamic friction is always smaller than maximum static friction and it's constant. So what exactly causes friction? People in the manufacturing sector who work with metal knows that more you smoothen the and polish the two metal surface, the more strongly they stick together if brought in contact. In fact, if suitably polished in a vacuum, they will stick so hard that they cannot be separated. We say that two pieces of metal have been cold welded. At the atomic level, when two surfaces come into contact, small peaks on one surface, cold weld with small peaks on other surface. Like that. Applying the initial sideways force, all of the cold weld oppose the motion. If the force is sufficiently large, the cold weld break and the new peaks contact each other and cold weld. If the surface remains in relative sliding motion, fewer welds have a chance to form. We define the unitless constant called coefficient of friction, which depends on a composition of the two surfaces as a ratio of friction force over reaction force. Since there are two types of friction, static and dynamic, every pair of material will have two coefficients of friction, coefficient of static friction and the coefficient of dynamic friction. In addition to the roughness and the smoothness of the material, the friction force depends, not surprisingly, on normal force. The harder the two surfaces are squished together, the more cold weld can form. Static friction is smaller and equals to coefficient of static friction times normal force, and the dynamic friction equals to coefficient of dynamic friction times normal force. A piece of wood with a coin on it is raised on one end until the coin just begins to slip. The angle the wood makes with the horizontal is 15 degrees. What is the coefficient of static friction? We have our free body diagram at the top. As the object is in equilibrium, resultant force in y component equals to 0. Weight has x and y component. and the y component is adjacent, and that is mg cosine 15 degree. So r minus mg cosine 15 degree equals to 0. R equals to mg cosine 15 degree. As the coin is about to slide, so resultant force in x component equals to 0. Weight has x component, and it is opposite, so it's mg sine 15 degree. Friction minus mg sine 15 degree equals to 0. Friction force equals to mg sine 15 degree. The coin is about to slide, so it is static friction. So static friction equals to coefficient of static friction times r. Substitute values, and mg's are cancel out, gives us tan 15 degree. Tan 15 degree is 0.268. Thus, the coefficient of static friction between the metal of the coin and the wood of the plank is 0.268. Now, suppose a plank of wood is long enough so that you can lower it to a point that the coin keeps slipping but no longer accelerates. If this new angle is 12 degree, what is the coefficient of dynamic friction? Now the angle is 12 degree, but object is moving with constant speed, which means resultant force in x component equals to 0. Resultant force in y component also equals to 0. Resultant force in y component equals to 0. Weight has a y component, which is adjacent, that is mg cosine 15 degree. R minus mg cosine 12 degree equals to 0. R equals to mg cosine 12 degree. As the object moving with a constant speed, resultant force in x component equals to 0. It is opposite, so mg sine 15 degree. Friction force minus mg sine 12 degree equals to 0. Friction force equals to mg sine 12 degree. As the object is sliding, it's dynamic friction. So dynamic friction equals to coefficient of dynamic friction times normal force. Substitute values, and mg's are cancel out. Coefficient of dynamic friction equals to tan 12 degree, which is 0.213. Thus, the coefficient of dynamic friction between the metal of the coin and the wood of the plank is 0.213. Newton's first law is drawn from his concept of net force and Galileo's concept of inertia. Newton's first law says that velocity of an object will not change if there is no net force acting on it. In his words, every body continues in its state of rest or of uniform motion in straight line unless it is compelled to change that state by force impressed thereon. Object at rest or moving with constant speed unless acted upon by external force. In symbol, if the resultant force equals to 0, then velocity is 0 or constant. Resultant force equals to 0 is a condition for translational equilibrium. As a memorable demonstration of inertia, matter's tendency to not change its state of motion, consider this. A water balloon is cut very rapidly with knife. For an instant, the water remains at rest. Don't try this at home.